Previously, we looked at the basic operation of arithmetic. In this video, we will look at what is a fraction. A fraction represents a part of a whole number. We have, for example, whole number which is equals to 1. The numerator is how many parts you have. The denominator is how many equal parts the whole is divided into. Let's look at a quick example. We have 3 over 4. 3 is the numerator and 4 is the denominator. Imagine we have a whole number which is 1, which represents a circle. By looking at the denominator, it means how many equal parts the whole is divided. The whole is now divided into 4. And the numerator means how many parts you have. That means you have 1, you have 2, and you have 3. Therefore, out of the 4 parts, you have 3, which represent 3/4 of a whole, which is 1. Similarly, if we look at 1 on 4, if we have a circle, that means the denominator represents the divisible into 4 parts, and you have only 1 part out of these 4. Imagine you went to a store and you want to buy a pizza. A pizza looks similar like this, and if you want to buy 1/4 of the pizza, this pizza represents the whole, and it is divided into 4 parts. If you want to buy 1/4, they will give you only this portion. If you want to buy 2/4, they will give you this portion and this portion. If you want to buy 3/4, they will give you this portion, and another portion. And if you want to buy 4, which is equals to 1, then that means you will get a whole pizza, which is represented by the 1 as a whole number. There are more applications that we will come across in relation to a fraction and what does the fraction represent. The important thing is understanding denominator and the numerator. Now we can see that there are different types of fraction, so we can discuss the types of fraction and what are they. The first one is the proper fraction. When we say proper fraction, what does it mean? It means the numerator must be less than the denominator, and this is the proper fraction. That means the value of the numerator must be less than the value that is found in the denominator. And secondly, we have the improper fraction. In the improper fraction, it is suggested that the numerator must be greater or equal to the denominator. This is meaning the value. We can also give example for proper fraction such as 1 on 2. We can see that the numerator is less than the denominator. And in terms of the proper fraction, we can say 5 over 2. That means the numerator is greater than the denominator. And thirdly, we say mixed number. So a fraction can be a mixed number. That means a whole number plus a fraction. In that case, we can say 2 and a half. So 2 is a whole number and 1 on 2 is a fraction. And fourthly, we can say equivalent fraction. When we say equivalent fraction, they mean that the fraction is equivalent. They are having different fraction, but they represent the same value. Example, 2 on 4 is also equivalent to 1 on 2, and it is equivalent to 4 on 8, and etc. All of them are equivalent, and this is the smallest representation of the fraction. However, 4 on 8, 2 on 4, they are also equivalent, but you can see they are represented differently. If you simplify, the lowest will be 1 on 2. And finally, we have like and unlike fraction. What does like and unlike fraction means? Like and unlike fraction represent the same or different denominator. Example, if we have 1 on 4 and 3 on 4, they represent a like fraction because of the denominator, and it is equivalent to, if we had them, they will give us a whole number. So such fractions are called like fraction. In a fraction, it helps us to understand the decimal and the percentage. So we will discuss in relation to the decimal and the percentage. Example, a fraction of 1 on 2, which have a decimal value of 0.5. If we want to get this 0.5, if we want to make 1 on 2, if we divide 1 on 2, it will give us 0, and we will add a 0. So by adding 10 on the numerator, it is now divisible. If we divide 2 divided by 10, it gives us 0.5. And to relate to a percentage, we all know that every percentage, we have the maximum value of 100%. 100% represent a whole. So we normally convert from decimal to percentage by multiplying a decimal number by 100% to give us a percentage value, and this is mostly important. In that case, we can see that if we multiply the decimal 0.5 times 100%, we will get 50%. So this 50% represent half of a whole. So the whole is 100 in percentage and 0.5 in decimal, and 1 on 2 represent the fraction. And fraction is mostly found in applications such as cooking, measurement, and probability, and advanced mathematics, especially the algebra. It is important for you to understand what is a fraction so you can apply in real life application. And also, this fraction is normally regarded as the ratio. Ratio having a numerator, which is a value, and a denominator. Let us look at example where we can apply fraction, decimal, and percentage together. Example, let's say resistor in parallel in an electrical circuit. That means you have a voltage source which is connected to resistor 1 and resistor 2. So let us say R1 is equals to half ohms and R2 is equals to 1/3 of an ohm. Therefore, R1 is equals to 0.5 ohms in decimal, and the R2 is equals to 0.333 ohms. So we are asked to find the total resistance. In that case, we have a formula. 1 times the resistance total is equals to 1 on R1 plus 1 on R2, which gives us 1 on 2 plus 1 divided by 1 on 3. Therefore, we can simply say we have 1 on 0.5 plus 1 on 0.333. Or you can simply, since it is divisible double times, this one can be on top and also 3 can be on top. So you can have 1 times 2 divided by 1 plus 3 on top. You have 1 times 3 on 1. So you have 2 plus 3 is equivalent to 5 ohms. And simply, if you use your calculator, you should have 5 into 1 is 2 times, and 0.333 into 1 will give you 3 times, which will also give you 5 ohms. And now we have 1 on the resistance total is equals to 5 ohms. So we normally transpose. We can do a transpose in that case, where you have 1 on 5 is equals to the resistance total. You bring this one to the other side, like divided by 1, and the 5 will be below. So it will give you 1 on 5 is equals to RT on 1. So you have the resistance total in this parallel circuit is 1 on 5, or is equivalent to 0.2 ohms. So we can now draw the equivalent circuit with the equivalent resistor like this plus minus. Now you have only one resistor which has a value of 0.2 ohms. We can appreciate the use of fraction in the measurement to find the total resistance value in an electrical circuit. And if you compare this in a parallel connection resistor, when you increase the number of parallel resistor in an electrical circuit, you are decreasing the resistance. And previously, we have seen that by increasing the number of a series resistor in an electrical circuit, you are increasing the resistance in a circuit. So by looking at the relationship, this represents the fraction and this represents the decimal component of the number. And in that case, this one represents the fraction, while 0.2 represents the decimal. Let us look at another example to summarize this section. So this example will correspond to a voltage divider. So a voltage divider is nothing but an electrical circuit. So we can have two resistors like this, and we have the Vout, and this is the voltage input. So when we apply some voltage input, we expect to get some voltage output. And mostly a voltage divider, the output is always a fraction of the input. So Vout is equivalent to the fraction of the input Vi. Therefore, we can see the term fraction in such voltage divider circuit. So let us give some form of data in a circuit. So we have V in, let's say, is a 12 volts, and we say R1 is equals to 1/4 of a ohms. Let's say R2 is equals to 3/4 of a ohms, and we have to find the Vout, which is the anode. So by using this value given, that means they represent a variable Vi, R1, R2, and Vo. So from a formula point of view, they normally give as a variable. So it is equals to Vout is equals to V in, and you have R2 over R1 plus R2. So those are variables that represent the value or the magnitude that can be found inside the electrical circuit. And we can see that this value are in fraction. So if we want to compute, we have Vout is equals to 12 multiplied by 3/4 of 1/4 plus 3/4. Since these two values here are in terms of the like terms, we can have Vout is equals to 12, and we have 3/4 over 1/4 plus 3/4 will gives us how much? It will gives us 1. 1 plus 3 we can simply add because we have the denominator, which is the like terms. So we have 1. Anything that is divisible by 1 will give us the value itself. In the previous example of division, we say any variable that divides by a1 will give us the variable itself, a divided by 1, which will give us a quotient of 1. So this is the rule. Therefore, we have the V out now is equals to 12 multiplied by 3 on 4. So we can simply cancel this. 4 into this 12 will give us how much? 4, 8, 12. It will give us 3. Therefore, we now have 3 times 3, which will give us 9 volts. So in this electrical circuit, that means we have 12 volts as an input. The output now will be 9 volts. In this voltage divider circuit, we have 12 volts coming in and 9 volts coming out. So we all know that this voltage divider is now responsible for dissipate 3 volts. This 3 volts is the loss within these two resistors to produce a 9 volts. And I want to extend. If these R1 and R2, they represent a constant magnitude, meaning the value is fixed. Therefore, we can have 12 volts is equals to 9 volts. This column represents the input equals the output. Imagine if we increase the input, because the input and the output we can vary. If we increase to 20 volts and you will have X to be solved, what will be the output? If you already have a data in place, then you don't need to do further calculation. You can just transpose by having 12 over 20 volts is equals to 9 volts over X volts. Make X becomes the subject of the formula. You now have X volts is equals to 9 volts over 12 volts multiplied by 20. So this can be your new equation. So we can say 2 into 12, you can have 6. 2 into 20, you can have 10. Therefore, you have the X voltage is equivalent to 90 divided by 6. And it will give you 15 volts. Now, when we increase the voltage to 20 volts, the output will become 15 volts. Therefore, 5 volts is dissipated by the voltage divider circuit. If you like our video, you can kindly subscribe and share with your friends so that they can be able to learn more of this interesting video series in mathematics.